Hello guys, welcome to CS50 Credit Walkthrough and Solutions. So today we're gonna talk about a few sections here. So we're gonna talk about the credit program, the pseudocodes, the input, the loop algorithm, card length, starting digits, the conditions for these three cards and the invalids, overload flowcharts, and remember to pause the video when we reach these sections. Then we'll go into the solution explanations. So the credit programs, when the user will key in the /credits, then the program will prop out the numbers to let the user to key in the credit numbers. So the user will key in something like this, around 16, 13 or 16 digits. The program will determine what credit number the card represent. Is it belong to Visa, AMEX or MasterCards, or just other than these three cards. So you can notice that if the user key in the something like some symbol here, the hyphens here, or some characters here, the program will reprop the user to make sure the user to key in the exact credit number, so which is the digit, only to let the program to determine which card is it. So for example, this digit is around 16 digits, is a Visa. If the user key in some credit number which is not belong into these three cards, will consider to go into invalids. So you can see this is AMEX, MasterCards, and Visa. So if you observe carefully, you can see there's a different characteristics of the credit numbers. You can see this is 3, 37s, or 5, or 4, or how many digit numbers. So in the program here, actually, there's a flow charts how the program go through one by one. First, the user will key in the inputs. Then the program will go into the loop algorithm. So the loop algorithm basically divide the credit number into two groups, and then just extracts some digits from the credit numbers and plus together. And the group 2 will do the same, which is not except it will not times 2, it will just plus together. So these two group will eventually plus together into one number. Then this number will be modulus 10. Then we find this last digit here. So the last thing from the loop algorithm is to find the sum of the last digits, which is the 0. So after that, we have to find the card length. For example, this credit numbers has a 16 digit. So we have to write some codes here to find the card length here. Then we also have to find the starting digits, which is the 4 and the 40 here, to find out which category of the credit number belong to this. So there's actually 4 conditions here. There's the AMEX, MasterCards, and Visa. Each of them have a particular conditions. For example, the AMEX need is 15 digits, start with 34 and 37. This is the condition that after we find, we can compare in with this green color box conditions. You can see digit 15 digit, which is actually linked with this, or this link with this. So for this case is the Visa here. So these three cards must pass the loop algorithm. That's why I put the box here. Other than that, if not passed, we will direct go to this invalid here. So after that, we check the card length. Is the Visa is 13 or 16? This is 16. So start with 4. So it's belong to the Visa. For the AMEX here, you can see these conditions. The card length here is 15. The starting is 37. So the condition is 37. So it's belong to the AMEX. Then we go to the MasterCards. There's a 16 digit here. So 16 actually can belong either the MasterCard or the Visa. That's why we have a few more conditions to determine which of these two categories. So you can see here the starting digit is 55, which belongs to the MasterCard. So at last, we have some credit numbers which is not belong to these three category. So other than that, you can see the loop algorithm is failed, and it, directly belongs to the invalids, and the cut length is 10. Okay, it's not even belong to these three category, and the starting digit is 6 and 61. So it's not here also. So we directly go to the invalids. So the pseudocode here we will include three libraries: CS50, standard IO, and max.h. So integer main, there's are 5 major steps in constructing the program. First, we're gonna prop for inputs only integer, which is this. Second, calculate the checksum loop algorithm, the cut length, the starting digit of the first digit, and the first and second digits, which is this. Then we will construct the conditions for this, the AMEX, MasterCard, Visa, and Invalid. So first we'll go through the first steps, which is the input credit numbers. So the program will reprop the user if there are consists of any non-integer, for example, the hyphens and the characters here. So if it's only integer, it will run the program and determine which category. So how can we construct these reprop functions? We can use in the CS50 example source codes here for the positive integer, a do while loop. This function will only accept a positive integer. For example, if the user key in -1, so we will compare with these conditions here, -1 and 1. So -1 is less than 1, so this is correct. If this is true, there will be a loop here to reprop again because this is true. For example, if the user key in 1, so 1 less than 1. So this is wrong. 1 is not less than 1. That's why it will break out from this loop. So that means we can confirm that the user is keying a positive integer. So we can do the same as this. What we do here is because you can see if you put integer here, we have a very long digit. So the integer is not able to store such a long digit. You can see the range here is the integer is 16 bits. We can store 5 digits. 32 bits we can store around 10 digits. Only the long can store around 19 digits. So we have 16 digits, we have to use the long. That's why here what we do is to change to the get long here. So the get long here is a functions that will reprop the user automatically if consists any non-integer characters, for example the hyphens here and the characters. So we don't need to consider any two here. We just basically put this get long here and just similar functions here we can put into our program. Next, we're going to go through the loop algorithm. So the loop algorithm is slightly more complicated. You can see from this, which is from the program CS50. So basically, it divides into group 1 and group 2. So first, let's underline every other digit starting from the number second to last digit. It will start from the second to last digit. So what we do here is the same, the group 1 and the group 2 here. So you can see here, this is the credit number. We use is the same credit number divided into group 1 and group 2. So now we're going to talk about group 1. So the group 1 you can see is extracting those underlined is 1 and 4. So 1 and 4 times 2. So basically, here got another 6 here. So what we do, we take this accept 0, we just times 2, here, 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 times 2. So we get the value here, which is actually the same here. There's the 8, 12, and 2. So after that, if there are a number which are 2 digits, what we do here, we just separate into these 2 here. So basically it's something like that. You can see it's same here. Plus together is 13. So how can we construct something like this? So just a concept. Basically, you treat it as a long digit. First, we have to divide, shift the decimal here, which you can see C divided by 10. So once here we get this digit by using a modulus 10. So we can get the 1 here. So the 1 will times 2. Times 2, then we'll check whether this value is more than 9. If more than 9, it will divide by, it will separate these 2 digits. So for example, for this 6 is more than 9, so it would he will separate these 2 digits equals to 1 and 2. So it will go a big loop here, it will go checking here, then it will C divided by 100, which is the decimal will shift to here. Then we get the 0. Later on, we will shift to here and go a loop, something like that. So roughly you have an idea. So starting we have to divide by hundreds, modulus get the digit times 2, check whether more than 9, separate, then continue a loop again, then continue until we go to these positions. So this is the group 1. So after we separate these two values, is 13, just plus put in into here. Then we go to the group number 2. Add sum 13 to the sum of the digit that will not multiply by 2 starting from the end. So since we are starting from the end, we just directly modulus 10. We get this 4 value. Then we check is it no more than 9? So it's not, so we continue by divide by 100, so something like that. Then we just modulus 10, we get 0. So you notice that I only got those have a value, which is 3 and 4. So 3 and 4 is not more than 9, so we just never separate both of them. You can see it's a 4 and 3 here, which is 4 and 3 here, 7. So plus together is 20, is 20 here. So let's do a modulus 10, then we get a 0 here. This is the value that we want. So once we understand this figure here, then we can roughly construct the code for this program in these sections. So roughly we write something like this for the group number 1. First we just shift the decimal, which is this one, shift. So once we shift is here, we just times 2, then shift to hundreds. So you can see here, this is after shifting. So check whether this is 2 digit, which is not 2 digit. So we just add these 2 into the pool. Yeah, basically we just add to here. Okay, so for this 2 digit, so if there are 2 digit, we just separate into this. Then we just add into the pool, something like that. So you can see this is how we just type it out from some sequence. So from here we can roughly construct a code. Then we can write something like a while loop and an if loop. The while loop is a parent's loop. So the if statements is inside here. So for the group 1, you have to divide by 10. Yeah, we just shift here. So we decline another variable here, a long, to divide by 10 because we just want to keep this credit number. So a big loop here is, consider this digit here is always more than 0. So what we do here, we just target to always divide into this condition to false, which is less than 0. So you can see here, long here, this is how we just divide. And from here, we just modulus 10 to get this 1 digit. After we get this 1 digit, we just times 2. Then we just divide by hundreds. Then you can see here, there's another loop here. Sorry, it's a if statement here. So you can see here is a single digit. So is it 2 more than 9? No. So 2 is not more than 9. It will directly skip to this area. So this digit will plus into this sum value. So what if we have a digit which is, for example, 12, which is more, 12 is actually more than 9. So basically we just separate these two. You can see here, for example, there's a 12 here. We modulus here. This will be the digit 1. Then we divide by 10. Shift a decimal here. Then we take this number as the D2 because we have another D2 modulus 10. So we can plus D1, D2 equals to D. So 1 plus 2 is 3. So the 3 will go to here and plus the current sum into the latest sum value. So from here, this is the code. Then you just compare again with this figure. You can see it's quite direct. You can divide by 10 is here. Then we have a big loop here. That's why you can see it's covering all here. Then in here, we will have to modulus 10, then times 2. Then we have this divide by hundreds. Then every number we have to check whether is it more than 9. If yes, then we just separate it, then plus here to here. Okay, so this is just the group 1. As for the group 2, it's easier because we don't have to put this anymore. We have the while loop, if statements, slightly the same. You just assume this is a long digit. So long digit will always try to shift it here to make this condition into the false. So we have to like a divide, which is this function here. First, we have to use this modulus 10 to get this 4 value. So we don't have to times. Just plus together. So we get the value, just check whether is it more than 9. So you can see this 2 is not more than 9, so no need to separate. If more than 9, you have to similar something like this. Just separate both of them and plus together. So for this case, it will just direct skip to here and plus to the latest sum here. So you can see it's quite direct from here. We don't have to put this and this times 2. So after that, we have this 7 and 13 here. 13 and 7. What we do here, we just add the sum 1 and sum 2 together into a total. Then we just modulus 10. Then we get this should be equals to 0 for the loop algorithm. So after we found the loop algorithm, we go to find the card length. So for example, this is the card length. We have to find how many digits here. So what we do here, we can use something in the exercise called integer overflow. It's using a while loop here. So for this example, the while true, the loop will always repeat itself here. This is like a forever loop. It's a 1. You print out 1 here, then wait for 1 second, then times 2. So it's always times 2 times 2 after 1 seconds. So we go like infinity. So we'll use this to find our cut length. So for example, this is a long C because it's a very long digit. Long can cover up to 19 digits. So from here, we declare an integer digit equals 0. So you see we use the while loop, which is very similar in the example. While the C is not equals to 0. So C is actually a very long digit. We try to shorten it until it become a false. Now it's actually true to false. So we have to keep dividing this number into a smaller. So while it's not equal to 0, the C will always divide 10. So the long expression is C divided by 10. So C is divided by 10 here. The digit plus plus. Initially the digit is 0, so digit will become 1 for one loop. So after he go to the second loop, it will become 2. Then go to 3, it become 3. Go to 4, it become 4. Then we calculate here. Then we will find that there's a 16 loop here. I mean 16 digit here. So we just print it out so you can see it's 16. So this is how we find the cut length. Next, we have to find the starting digits and the first and second digit. So you can see here the 3 cuts here. We have something like this: start with, and start with. So we need to find the credit card number of these two value. So we just put it as two variables here: the first digit and the second digit. So in the video by the Brian, he gave us some tips about how to find the last digits. So integer, FD, the credit numbers, modulus 10, we can find is 4. If you want to find the second digit here, so the easiest way we think is just add a 0 here. But we always, if this case, we always get 4 here, which is not what we want. We want to get the 1 here or the 14 here, not 4. So the correct way to get the 1 value is to divide the credit number, shift the decimal to 1 point here, then we do a modulus to get this 1 here. So divide by 10, then modulus 10, we get 1. This is actually the correct way. So for finding this digit here, we will use a slightly different methods. What you use here is just integer FD, integer FSD. So integer will always capture the digit without decimal. So you can see here, we just the credit numbers divided by 10 to the power of 15. It means that we just shift here 15 times, will go to here. So it will become 4.00 something. Since it's the integer will only capture the number of 4 here. For the first second digit, same. We shift the decimal here to 14, which is going to be here. So it will be 40.03 something. But since it's the integer, we only capture this 40 here. That's why it's here 40. So to make it more simpler in our coding, we just convert to here POW bracket 10, 15. So 10, this is power, the meaning of power, POW. 10 is the power of 10, and the 15 is the power of 15, something like 10, 15, 10, 14. So when we put it here, for example, if you put these two as a fixed variable, we may not able to achieve what we want for the different digit length. For example, I put an APEX here, which is 15 digits. Using the same methods, what we get here is 3, which is 0 or something here. Then 14, we get 3, which is not what we want. What we want here, we want to get 3 and 37. So this is not the correct, not the most accurate way to do it. So since we find the cut length here, we can use this variable here. So something like that, we just put the credit card number here, PO, and the digit length. For example, this is 16, so it's 16 minus 1, which is 15, which is the same here, 15. So we find the 4 here. So for here, we just the digit length minus 2, which is 16 minus 2 equals to 14, which is the same here, which is 40, same. So you can see here is MAX is 15 digit. 15 digits minus 1 is 14 digits. So 14 digit, it will slightly shift to this position here. So we get the number 3 here, which is correct. Same here, shift to here, 37, which is what we want. So we can use this method to find a different credit number length for this first and second digit. So at last, we have to set some conditions here for the AMEX, MasterCards, and the Visa, or the invalids. So how can we construct this requirement into our program in the coding? So what we have now is the sum of the last digit with the loops algorithm, the cut length, first and second digit. So what we use here is something like a if else if statement, and we can use something like or here. You can see or. Yeah, definitely we can apply this, and something like an and here, a logical operator between these two. And for else, we can use for this invalid, because if these 3 conditions are not fulfilled, it will automatically go to the last condition we choose for the else. So let's try to construct one credit card conditions. We start with AMEX. So AMEX is 15 digits. So before that, we have to assume all the loop algorithm, the sum last digit is equals to 0. You can see there's an AND operation here. The cut digit must equals to 15, and the first 2 digit is 34 or 37. So there's 2 AND here, and there's one OR operator because of here. So the program will sort it up and determine, oh, this is a max. So we can use the same concept here to construct the MasterCard and Visa. Else, we can just put invalid. So let's look at the overall flowchart here. You key in the /credit, the program will prompt the number, key in the credit card number, the program will determine which card is it. So the program will, first we're gonna have the first step, input credit card number, make sure it's a positive value here. Then we'll go through the loop algorithm, group 1, group 2, then the modulus. So we get the sum last digit using the while loop and the if statements. Then we'll find the cut length using the while loop. Then we'll find the first digit and the second digit using this formula here, the digit length -1, digit length -2. So at last we have to construct the condition for this 3 cut or else the invalids. Then we use these two if-else statements, the logical operator of the OR and AND. So now pause the video and try to solve it before continues to the solution sections. Alright, welcome back. So let's go into the solution explanation sections. Okay, so this is the program that I wrote. So first we're gonna include these 3 libraries, CS50, mesh.h, standard.io.h. In the integer main voids, we have a few important sections. The first is the input the credit number, the long credit number, do while loop. User key in the credit number, 16 digits. We use the get long, then check the conditions. If the conditions is more than 0, so we skip here, we just break out from this loop. This is sum of the variables that I decline here. So the sum we decline is equal to 0. Let's do sum here. So first group here is the loop algorithm group 1, which is we need to shift one position to become the odd. Then we create a while loop and an if statement here to check whether is it more than 9. So first we're gonna get the first digit after shift divide by 10. Then we just shift the credit number decimal by divide hundreds, then times 2. Then if this digit is more than 9, we're gonna separate into these 2. And after we separate these 2, we have to plus together into these digits and put it here to sum. So this is how we get the sum for the group 1. So this is the group 2. So the group 2 will start from the last digit and repeat. So we just copy the credit number into the credit number 2. The same concept, the while and the if. So the group 2 is much more simpler. We just have to get the digit by modulus 10. Then we shift the decimal by divide by hundreds. And we check this digit whether more than 9. Is it 2 digit? Is 2 digit, we're going to separate into 2 and plus together. After that, we plus these 2 digits, or if not 2 digit, we just put it into the sum here. We just skip here. Then we get the sum for the group 2. After we get the sum of the group 2, we have to plus these 2 together into the total. Then we just do a modulus 10 to get the last digit. If this is 20, we just get 0 for the condition checking for the different cuts. Then we go to the cut length. So we just clone the credit card number into this variable. Let's decline equals 0. So we do a while loop, like an infinity loop just we explained previously. If the credit digit is not equal to 0, so in here we have 16 digits. 16 digit, we have to make it into 0. So common sense, we have to just shift the decimal by dividing. So every shift will plus 1 as a tracking. So that's how we track the cut length. So next, after we found the cut length, we just put it here. You can see the variable is the same here. basically we just take the credit card numbers and divide to find the the number. For example, you can see here there's a 1 2 3. So to the power, we just shift here and shift here. We just take the 1 as the first digit. So the first digit is just minus 1, the second digit minus 2. This is how we get the first digit and the second digit. So the last, we're gonna print AMEX, MasterCard, Visa on invalid. This is the conditions which are mentioned in the previous PPT. You can see the loop algorithm. Every card must equal to 0. So some of them have a different digit number. You can see here. Some have an OR condition for the Visa, and we have the first two digit 34, 37 for the MX. So for the MasterCard 0, digit length 16, first digit is 51 or 52 till 55. We have at least 3 conditions here for each card. So same here, loop algorithm equal 0, digit length is 13 or 16. Then the first digit must equal to 4. This is the Visa conditions. If the credit number is not within these 3 categories, it will go to the invalids. So let's try the program here. Oh, let's see. CD. Okay, let's do credit. Okay, let's paste a number here. So it's Visa. So what if we key in some value? So it's invalid. So what if we key in something like this hyphen? Also we try to reprop again characters, reprop again until we key in a proper digit. You go into the invalid. Okay. So first sections, input credit number, loop algorithm group 1, loop algorithm group 2, others, a card length, find the first and second digit number, then the conditions for the 4 cards, for the 3 cards, else invalid. So that's it. Thanks for watching and see you next time.